Welcome back, guys. I know it's been a long time coming. It's been several months since I've posted my last update video on my Reefberry Pi DIY aquarium controller, so I'm going to bring you up to speed of where it's at, what I've got accomplished in the time since the last you've seen this. So let's get right into it. I think the last time I gave the update, I was showing my energy bar that I had made. You can just watch the last video. I got really into detail how I did this. Nothing much has changed here. Actually, nothing's changed on this. Still as it was the last time you saw it. I can control these 8 outlets individually. But what has changed is I now have everything inside of a project box. Actually, I have multiple project boxes, which I'll show you what's in each one of these. So part of the reason why there's been such a long delay, I bought the first box on Amazon, and this thing wasn't cheap. It was like 21 bucks or something like that, something crazy. So I wanted a few of these because I'm going to make a couple of these controllers, and I need multiple boxes for each one. So I went on the eBay and I found same box for much cheaper. I think it was like $14 each. So I ordered a few of them. The problem is that they had to come from China. And the shipping just took forever. It took like a month to get here, so I just kind of put everything on hold until I got the parts that I needed. But anyway, everything's here now. So I went ahead and I have, obviously I had to modify the side panel here to get all of the ports in here that I wanted. But quickly, what I have right here is the Raspberry Pi. That's the computer that's running everything. On top of the Pi, there's this Pi Easy Connect hat. It's basically just a breakout board that sits on top of it and has all sorts of nice little spots where you can easily attach your wires and everything. All these little breakout spots. I forget what you call them. Standoffs, whatever. Those things where you can screw your wires into. So that's right here. And then I cut out the hole so I can still access my Ethernet, USB from there. And then, I was controlling this thing with a standard, USB power brick. But what I've decided to do instead, you'll notice normally the Pi runs on 5 volts. This is 12 volts. I've got a 12 volt power brick coming into here to power everything because I've got more than just the Pi that needs power. So the 12 volt comes in and it heads over to this board out there. It says 12 volts on it. And then that splits it off over to here where it says 5 volts. There's a little step down transformer on here. And I've got that tuned, so it takes the 12 volts, tunes it down to 5 volts. And then I just feed that directly into the GPIO headers on the Pi to feed the power into there. You do need to be careful when you wire it up this way. If you do it incorrectly, you probably fry your Raspberry Pi. So make sure you know what you're doing first. Fortunately, I was able to learn how to do it, and I did not destroy my Pi, and it works. That leaves this other step-down transformer over here, which is not in use at the moment. I will be taking more power off of the 12 volts, and I will be converting that down to 10 volts and feeding that over to here, which I will have a pulse width modulation circuit, which I intend to use to control things like my Kessel lighting. Not done yet, but that's, in the works. So what else did I have on here? DHT is a digital humidity and temperature sensor. I'm just using a standard headphone jack to connect into that. And again, that wires into the Raspberry Pi. I got 2 other serial ports here, just DB9 connectors. I have them wired into the Pi as well. The one on the bottom, I used this little breakout board. Probably wasn't necessary. I could just use a standard connector and just solder everything onto it. But anyway, that's what I did there. And then over here, I found this nice breakout board for my temperature probes. And this is just an RJ11, your standard telephone jack. That's what I use to connect my temperature probes. And that gets wired over into the Raspberry Pi as well. Then these two, I picked different style plugs. One's male, It goes, male to male. The other one goes female to female, so there's no possibility to connect the wrong wires together. So the outlets will connect into here to control those. And then the analog probes go into this other box where this is going to connect into this analog to digital converter. This has 8 channels. In the past, I only had a 2-channel board wired up. So in the time that you've seen this last, I've designed it. I now have access to all 8 channels for that chip there. So it took some doing. So yeah, I've got all 8 available to me now, which means I could potentially have 8 probes hooked up to this thing. I've got 3 at the moment. So I have 2 pH probes. That's these ones with the blue on them. Channel 0 and channel 1. And channel 2 I have connected to a salinity probe or salinity monitor. And again, that's just the standard DB9 connecting it all together, which feeds the power and all the communication lines come through there. So yeah, that's just a quick rundown of what the hardware looks like. And I'm going to go ahead and connect it all together. We'll do a live demo. Let's see what works, see if we can blow this thing up, see if it actually does what I think it does. Let's give it a shot. So let me grab some wires and we'll take a look at it. So I've got everything connected back together with the equipment, and I'll show you over here. We've got a little simulated reef tank set up that we're going to use as our test bed for today, this demonstration. That's got all the basic stuff that you would expect. Return pump. There's a heater in there, wave maker, skimmer, and light. So we'll just pretend that this is an actual reef tank and see if we can control that equipment. So first of all, let me log into the Pi. This is all booted up now. I just need to connect to it remotely. And let me log into my computer and I'll show you that in just a second. So I generally use VNC to log into the Raspberry Pi. It just makes it easy to do through this interface. So when it boots up, the server just starts running. It's over here in the background. But right now I am interacting with it through this little application, which will start up in just a second. And that makes the connection over to the server and allows me to do all the configuration and everything. And I pretty much wiped everything out. I want to kind of set it up from scratch here to show you how configurable it is at this point in time. So on this screen you could see that there are 8 outlets available to us here. And these 8 outlets correspond to the 8 outlets right there. I'm going to hook our equipment up to that energy bar. And I'm only showing right now one of the probes. I have the temperature probe configured, and that's the temperature probe that is inside of the tank here. It's back there somewhere behind a skimmer or something. So first thing let's do is let's configure our probes. So if I go into settings, obviously you can change the temperature scale. I'm going to leave it on Fahrenheit for now. I go into temperature probes, and this is that first probe that I have configured. And you'll notice unassigned probes. I can hook up to 4 probes up to here. Actually, I could hook up as many as I want it, but 4 is probably plenty. And that's what the little board supported there. But each one of these probes has a serial number, so you just have to know what that is for each one if you want to know what you're looking at. So I put a little label on that one so I could tell. And that one ends with BFF. There it is right there, BFF. I'm going to add that probe. And we need to give this a name. We're going to leave this probe, here it is right here, just sitting out in the air. So we'll just call that like the air temperature. You can name it whatever you want. We'll call it air temp. There we go. And we'll save that. Okay. Environmental, this is the DHT sensor, which is back here somewhere. So this little blue sensor measures temperature and humidity. So we're going to connect this as well. And this one is connected right there. And we'll just leave that aside. And so let's go ahead and enable that. And again, you could rename these if you want. I'll just leave them room temperature and relative humidity. I'll save that. Switches. I am going to be adding switches onto here, so float switches and stuff. Not here now, but it will be soon. Analog probes, that's all those guys. So we've got 3 probes right now. So I know that on channel 0 is my double junction pH probe. And I've already got that labeled there. And you can check or select what type of readings it's going to be taking. That's a pH probe, so we're going to leave that as pH. Channel 1, which is my single junction pH probe. And I've just got some probes from Bulk Reef Supply. So there's a single junction and a double junction in there. And this other one, it's my salinity probe. And that's a bucket of salt water from my reef tank. This is all just fresh water. That's why I'm not measuring that. So that's also measuring pH and salinity. I don't have all of the salinity functionality working yet, but it's working well enough. But right now I'm going to have to choose sensor type raw, just the raw data off of there. That'll work for now. And we're going to hit save on that. And I think that's all we need to configure. We don't have the pulse width modulation yet. So all that's set. So now what I need to do is, before they all show up here on my dashboard, I am going to need to restart this application. So let's do that right now. And just for good measure, since I've changed a few things, I don't know if this is necessary or not, but I'm going to restart the server. All right. So now when we come back into the application, we should see all those probes that we just enabled, and they should start feeding data off of the server. And just initializing all of the controls. And there's all of our probes. And the data should start feeding in any second now. And as it gets updates, it will update the labels there. Okay, so now we can go ahead and set up our outlets. So we have all of our equipment. So why don't we start with the lighting. That's this huge power brick. I'm going to stick this into outlet number 1. And since that's lighting, let me come over to here. And we'll go to outlet number 1. And I'm going to configure this. I'll just call this lighting, and the control type will be a light. And you can pick the on and off times. So we'll do from 8 in the morning until 7 at night. Sure, sounds good. And we'll hit OK for that. Outlet 2, let's plug. This is a power head. All right, we'll put the. Why don't we put our return pump into power outlet number 2? Okay, that's my return pump. And I'll call that a return pump. Now here's where we'll get to make a couple of decisions. I failed to mention before, but there are some feed modes. So you could program up to 4 different feed modes and set that for as long as you would like. I think I have feed mode A set to 1 minute right now. So what'll happen is when I click on A, it'll start a 1 minute timer. And since I have the checkbox next to A, it's enabled for feed mode A. It'll turn this switch or this outlet off. And then when the feed mode has expired, it'll turn it back on, but it's going to give it an additional 15-second delay, which we'll see in just a moment. So let's say OK to that. OK. And then outlet number 3. And you could see that it just kicked on. So outlet number 3, let's maybe use our skimmer. And I think this is the skimmer plug. And let's give this type skimmer. I will also check for feed mode A, and that'll have an additional 30-second delay on it. So the return pump will come on 15 seconds after the feed mode expires, and the skimmer will come on 30 seconds after it expires. And, you know, if you've ever dealt with, you know, a real reef tank with a sump and everything, generally you'll need to run your return pump first, give it your skimmer a little bit of, or give the sump some time to equalize, then turn your skimmer on, because otherwise it could start to overflow. And we've got B connected, it doesn't matter. I'll say OK. And then outlet 4, why don't we connect in? You can see that just kicked on. Skimmer. All right, so 4, we'll connect the wave maker, I guess, which is, that's the heater. Well, we'll do heater. Number 4 will be the heater. And then we'll select type. And I'm going to probably extend this list of different control types. This is all that I have right now, but I could imagine, you know, several other types that'll probably be useful here. But that's just all I'm starting with. I'll call it heater. And then here's where you get to choose which one of those temperature sensors the heater will be keying off of. Since we've got one called display temp, which is the one inside of there, we're going to select that one. And these are the on and off points. So that looks good to me. I'll hit OK. And I think we just had the wave maker left. And there's the power head. I'll put that into number 5. And let's go to outlet 5. And we'll rename that. And we'll call it power head. And we're going to give this the same, we're going to give a control type return pump because I want it to be able to react to these feed timers. So we'll say yes, let's enable it for feed mode A, and we're not going to put any additional delay onto that. We'll just say OK to that. And now all of our outlets should be configured. We don't have anything to plug into 6, 7, and 8, so we'll just leave them alone for now. And then here's the feed mode. If I come in here, it's where you can configure the timers for each of those. So since we just set this all up, let's just test everything's working. So lighting, if I click off, you heard the click, just turned it off. Return pump, off, turned it off. Skimmer, off, turned it off. And you get the idea. You do the same thing for the heater and everything else. If I hit auto, it's going to run the program that we put into there, which means it's going to basically run whatever we had set in here. So you have the option to turn it completely off, just keep it on, or run the program. So we're going to hit auto. We're going to run all the programs. which means now if we hit A, feed mode A, these should react according to the programming that we put into there. So we're going to do that now and hit A. And we're now in feed mode A. And we had that configured for 1 minute, so it's starting a 1 minute countdown. Which means all the stuff will just sit off for the time being. And now we wait. So the feed mode is about to expire, which means the way we had it programmed is once it expires, the wave maker should turn on first, which it just did. And then 15 seconds later, we should have our return pump turn on. It should be coming on any second. There we go. And then after that's on, so this was set to 30 seconds, so 15 seconds later, our skimmer should kick on. Which it just did. So it looks like all of that is working, which is pretty cool. I'm happy with that. And yeah, so that's, well, that's not quite all. So there's still some things that I'm working on in regards to mostly with the analog probes. So I click back over to here. So I've been working on calibrations. So I now am able to run up to 8 devices independently, and all of these can have their own calibrations assigned to them. So I've gone ahead and written a nice little utility, if I need to calibrate any of these probes. And this is the user interface for that. And what I'd like to do is just kind of bring up another instance here so I could have it side by side. I'd like to show 2 probes together. So while that's starting up, I do use a 3-point calibration. Let me show you the calibration fluids I have. So I bought a pack of calibration fluid from Atlas Scientific, and it comes with 3 references, 4, 7, and 10. So I've implemented a 3-point calibration here. There's the 2 boards there with the green lights on them. And right now I have 2 different probes connected. So the yellow one is a double junction probe from Bulk Reef Supply, and the silver one is the cheaper single junction probe. So I am noticing a slight difference in the numbers that they are reporting back. Let's just bring that up. So that's the double. Let's see the single. So I've got them both in that bucket there with some tank water. And I do notice that there is a slight difference there. And I have calibrated these probes, and I will do it again just to verify. But yeah, still something not right there. I just think that those 2 probes do not follow the same characteristic curve, maybe. They have different tolerances. I'm not sure. I can't really find any technical data on those probes, so I really don't know what their stated, accuracy or, what the tolerance is on them. But they're pretty darn close, to be honest. But as I get to the calibration points, they are spot on. So there's something a little bit off on the way that they're behaving. And I've checked the calculation several times. I think I'm doing everything right, so I need to work on this a little bit more. But let me get the probes in the reference solution, and we'll take a look at it there. All right, well, I didn't catch it on camera, but I may have figured out what was wrong, or at least it's going to put an end to my investigation for the time being on why these probes are reading differently. I was just rinsing them off in some RO water, and I got a little rag. I just dabbed the ends of the probe to clean them off, dry them off, so I don't contaminate my calibration fluid. And when I was dabbing the double junction probe, I don't know if you could see that. There's a little glass bulb on the end. It just completely shattered. I don't know, maybe it was cracked, and that's why it wasn't reading what I thought, but now this probe is garbage, and this really sucks because this was the expensive one. So, yeah, that's unfortunate. I guess these things happen. So my $60 probe is now a piece of trash. But anyway, we could still demonstrate the pH with the probe that is still working, which is the single junction probe. All right, so it is now in the yellow solution, which is pH reference 7. Let's close this. I am really bummed about that probe. Those things are not cheap, so anybody wants to donate a probe, get in touch, because I'd love to continue working on this, and now with only a single probe, it kind of throws a wrench in the works. Anyway, all right, back to the to the demo. If something didn't go wrong, it wouldn't have been a demo, right? So anyway, I've got that into 7.0 reference solution, which is my mid, and we're reading 6.94, 6.92. That's pretty darn close. But let's say that we were going to be calibrating this anyway. I could click on Start Mid Calibration, and it's going to start acquiring data points. And the way I have it set up right now is it will grab 120 data points just to calculate out where my target value should be. And this number represents the A to D counts that are being read, because those probes are sending out an analog voltage. The Raspberry Pi will not read that, so they send the data in here, and this converts it to a number, which is being read right here. So basically that number 749 equates to 7.0 or whatever this number happens to be at the end. And probably just come back to this in a minute when this gets closer to being finished. No need to sit here for 2 minutes and watch that acquire data. All right, so it's approaching the 120 data point, 120th data point. So once it hits the final point, calculates out a histogram. And I don't know if you noticed while it was acquiring data, but these numbers were updating in real time. Just some stats there. The important things, well, obviously, is the calibration value, in the end. Standard deviation. So if you know anything about, statistics, math, whatever, it's basically a gauge of how good my data is. So my data points were falling, within a standard deviation of 2.81, which is pretty good. I've noticed, if I'm getting good data, it's usually under a standard deviation of 3. And then I calculate, those lines, I plot them on here. So anything that falls outside of that range, I consider outliers, and I am not including them in my data set when I do my final calculation for my calibration point. So if I was happy with that number, I will say apply the calibration value. It says me, okay, the mid calibration was applied. I see that's now green. That means, yes, I just calibrated it at that point. And I'm going to go ahead and do the same thing for the low and the high. And then we should have a fully calibrated probe. So I'll be back in just a minute. Okay, so the probe is now calibrated. And it's reading, 8.0, 7.98, which is about what I would expect out of that sample of water that was out of my reef tank. So that's probably a pretty accurate number, I would say. Salinity, still have to work on that to do the calibrations. But right now, if I were to divide this by 10, 34.7 is basically what my reading would be. I just haven't finished doing all the stuff I need to do with it. And I still need to do the calibrations because that is temperature sensitive. But that's about the right number for salinity as well. And then the graphing feature, which I have here, which you could overlay certain graphs. So any of the outlets or probes where you're recording data. So here's the 2-week plot of my pH probes while they were. Let's go pH probe versus, see if I can go to this one. Okay, so these were the two probes that I had, the single junction versus the double junction, while it was still alive. But you could see, over the 2 week period, even though these weren't, calibrated properly, the numbers aren't exactly right, but you can see that it was following the pH cycle that you would expect in your reef tank, where during the day it goes up and up and up, lights go off, it drops down, and it's up and down. So I had this running on one of my reef tanks just to test that the numbers were looking good. Until I got down to here, I started messing around with the calibrations. That's why everything was just kind of crazy. All kinds of garbage got recorded. But while it was just sitting there, it was doing the nice up and down that you would expect. And then other things like I've renamed all these outlets, so I don't know what was what anymore. But yeah, so I think that's about all there is really to show at this point. If you guys have any questions or anything, feel free to leave them in the comments. And let me know what you think. And if you want to see more of this, you got to hit that subscribe button and follow along, because I do try to put out updates when there's stuff to share. And I guess that's about it. I guess we'll be signing off for now. I want to thank you guys for watching, and I will catch you in the next one. Take care.